Alright, number 9. Express the complex number in trigonometric form. So we already kind of did a problem like this where we had to do something else with it though. So it was a little bit different. So what we need is to be able to write this in trig form, which it looks like this. And so what we need to know is r and theta. The r we get by doing basically a Pythagorean theorem kind of situation where this first number is a, the number in front of I is b. So in this case we would do the square root of -5 squared plus 5 square roots of 3 squared. And if we work that out using our calculator or whatever, we get square root of 100, which is 10, and then we need our angle. So this point, -5 plus, or this complex number, -5 plus 5 square roots of 3i, is also a point in the complex plane where you go left 5, because it's -5, and then up 5 square roots of 3. And so we can look at that triangle. And the other thing we can do is, this is really a special right triangle where if we divide both of these by 5, then we'd have -1 square root of 3, which means this side is 2, which means that the angle inside is the angle that's across from square root of 3, which would be pi over 3, because it'd be like 60 degrees. But we want the angle to get around to that, which means that we want 2 pi over 3. So theta is 2 pi over 3. The other way to do it would be to do inverse tangent of 5 square roots of 3 over -5. And you'd want to do that in radian mode, and I think if you plug that in, you should get 2 pi over 3, but it won't be in that form. It would give it to you as a decimal. So if you had a multiple choice situation going on, you could still figure out which angle was right, basically that way. But we need to plug this in. R is 10, theta is 2 pi over 3. So here's that complex number in trigonometric form. Find an equivalent equation in polar coordinates. So when we are converting between a regular equation to a polar equation, we need to remember this conversion thing right here. X is the same as r cosine theta, y is the same thing as r sine theta. So we have an x and a y. We need to plug in the r cosine theta where x is, and we need to plug in the r sine theta where y is, and then distribute that squared. So this is r squared cosine squared theta plus 4r squared sine squared theta equals 4. And if this was multiple choice, the answer choice we would be looking for, they have the r squared factored out for whatever reason. So this would be the answer choice we'd look for. Graph the parametric equation. So we have x equals 2t minus 1. We have y equals t squared plus 2. They're asking us, or they're saying that t is between -4 and 4. And so without the calculator, what we would basically do is make ourselves a table of values where we have t, x, and y. So like when I plug in a -4 for t, I plug it into the x equation and I get 2 times -4, which is -8, minus 1, which is -9. When I plug -4 into the y equation, I get -4 squared, which is 16, plus 2 is 18. So this is one of my points at -9, 18, where at time equals -4, or t equals -4. I guess we don't know that it's time necessarily. Okay, well that's not on my graph that they've provided. So now I could look at -3. And so you plug in -3 for t in both equations. So you just keep plugging in and plugging in. Or we could switch our calculator to parametric mode and put these two equations in for x1 and y1, and then our calculator would graph it. If that's your plan, that you're planning to do that, I would practice because the window might be weird, and so you need to make sure you know remember how to set the window. If I graph these on my page, then like I can easily graph -1, 2. It'd be up here, and then the points around that, like 1, 3, and -3, 3, and then 3, 6. And so basically what's going on is this is a parabola. So we would look for the answer choice that had a parabola that looked closest to what is either on our calculator or on our paper. Eliminate the parameter. So to eliminate the parameter, we solve one equation for t. So that requires me adding 3 to both sides. If you solve the x equation for t, it saves you time because then when you plug into the other one, you don't have to worry about solving for y. It's already solved for y. So we need to FOIL this. That's x plus 3 times x plus 3. Nine plus 15 is 14. So there's my answer. Alright, number 13. We want to write this circle as a parametric equation. So there's a formula that would be helpful, that for a circle, our parametric equations consist of x equals h plus r cosine theta, y equals k plus r sine theta. And so h and k are from our center point, r is our radius. So in this case it would be x equals 6 plus 8 cosine theta, y equals 7 plus 8 sine theta. Here's another roots question. Find the fifth roots of this and then write the answer in trig form. So you already have the formula written down. We did that on number 6, so go back and look at it if you need to. In this case, our r is 243 and our theta is 260. So we are doing the fifth root. So the fifth root of r would be the fifth root of 243 times cosine of theta, which is 260, plus, since we're talking about degrees, this is 360k over n, plus I sine 260 plus 360k over n. And then we need our k's to be from 0 to 4. 0, 1, 2, 3, 4. So the fifth root of 243 is 3. Okay, this is for k equals 0. Cosine of 260 degrees plus 360 times 0 over 5. If we simplify this, we end up getting, oh, that was times 0. We get rid of those, so 260 divided by 5 gives us 52. So this is 3 times cosine 52 plus I sine 52. And then we do k equals 1. So 260 plus 360 times 1 over 5 gives us 124. So 3 times cosine of 124 plus I sine 124. Now, k equals 2, k equals 3, k equals 4. It's going to work out the same way. So once you plug in the 2 and simplify, for k equals 2, you'll get 3 cosine 196 plus I sine 196. For k equals 3, you'll get 3 cosine 268 plus I sine 268. And for k equals 4, you get 3 cosine 340 plus I sine 340. So there are your 5 roots of this number. Find the logistic function that satisfies the given conditions. The formula for a logistic function is y equals c over 1 plus a times b to the x. And from this information, the only letter here that we know is c. The limit to growth in these situations is always going to be c. So that means that on top of our equation we can put 845. Now, they told us a point that it passes through. They also told us the initial height is 169, which means we actually know another point, because the initial height would happen at 0. So we know 0, 169 is a point. We're going to start off by plugging in that point in for x and y. So 169 equals 845 over 1 plus a times b to the 0. That means the b goes away because that would be 1. So we really have 169 over 1 equals 845 over 1 plus a. So we're going to cross multiply. And then we could distribute, or we could just divide by 169 right now and get 1 plus a equals, we need to do 845 divided by 169. You get 5. So you subtract 1 and you get a equals 4. So now we know c and a, we just need to figure out b. So we're going to plug in the other point, the 2, 585. So 585 equals 845 over 1 plus a, we said was 4, times b to the second power, because x is 2. We want to cross multiply again. So this is 585 times 1 plus 4 times b squared. I could have just written that as 4b squared, not 4 times b squared. Divide each side by 585. So you get 1 plus 4b squared equals 845 divided by 585. Change it to a fraction is 13 over 9. Subtract 1. 4b squared equals 4/9. Because 13 over 9 minus 9 over 9 is 4/9. Divide by 4. So that's b squared equals, dividing by 4 is like multiplying by a fourth. So that's 1/9 square root. We get b equals 1/3. So that means that our equation would be y equals 845 over 1 plus 4 times 1/3 to the x. solve the equation. We have logarithms. So the important thing to remember is that each thing inside of our logarithm has to be greater than 0. So before we start messing with this equation, I would like to look at it and say, okay, 3x has to be greater than 0. 2 has to be greater than 0, but duh, it already is. X plus 5 is greater than 0. Of these two, this first one means x has to be greater than 0. The second one means x has to be greater than -5. Well, which of these two things is more restrictive? This one. There are more numbers if x has to only be greater than -5 than if x has to be greater than 0. So this is the domain of our function. So if we end up with an answer that doesn't fit that, then we'll have to reject it as not really being an answer. Now that we know that, we can use the properties of logarithms on the right side here. This is addition, so we can combine these logarithms using multiplication. So that means let's distribute that 2. And because these logarithms have the same base, they're both log with a base of 10, or common logarithms, or whatever you want to call it, well, we basically can set the inside of the logarithms equal to each other. So this is x equals 10. That does fit this. That makes that okay. So x equals 10 is our answer. Describe how to transform the graph of the basic function g of x into the graph of the given function f of x. So how do we get this graph if we start with this one? What do we do to it? How do we move the graph? Well, a +3 on the outside of our parentheses here means that we're shifting, or if you want to use a fancier word, we're translating up 3 units. The -4 on the inside means that we are moving left and right, and since it's negative, we do the opposite, and that means it's moving right 4 units. So we're translating up 3, we're translating right 4. Rewrite the expression as a sum or difference of multiple logarithms. That's just asking us to expand this logarithm. Oops. We're doing 25 times x, so we would split that up into addition. And then let's pretend that wasn't an answer choice. Something else we could do to this is we could change 25 to 5 squared. Let's pretend that's not an answer choice, because why would it be, since we can move the exponent in front there. So maybe this would be an answer choice and it would be a correct answer.